Hi, my name is Courtney Richardson, and I'm going to be doing a presentation on blood constituents and functions. So, first off, let's talk a little bit about the components of blood. It is made of four major components and considered to be a connective tissue, providing transport of material throughout the body. Blood consists of four parts mixed together: plasma, erythrocytes, leukocytes, and platelets. Each piece is essential to maintaining homeostasis through providing nourishment to other areas of the body, forming a defense system against foreign invaders, removing waste, transporting hormones, and preventing bleeding when tissue is injured. Blood makes up roughly 8% of an individual's total body weight and averages around 5 liters for women and 5 liters for men. However, during pregnancy for women, the volume can increase by 30 to 50% in total. So let's talk about plasma first. Plasma is a complex liquid that contains the red blood cells, white blood cells, and platelets within it. Plasma accounts for about 60% of the total blood volume, um, while the red blood cell proportion makes up the majority of the remaining volume. So plasma is about 90% water and absorbs and distributes heat that is generated through metabolism within the tissues. This helps with homeostasis. Organic and inorganic substances are dissolved within the plasma. Most abundantly, we have electrolytes such as chloride ions and sodium ions. Additionally, other ions are dissolved in plasma, such as bicarbonate, potassium, and calcium, as well as others. Plasma helps to provide ions to promote membrane excitability, fluid distribution between the extracellular areas in cell membranes, and pH balances. It also contains plasma proteins, which are dispersed as colloids and do not dissolve within the water. Plasma proteins are albumins, globulins, and fibrinogen. The most common form of plasma proteins are albumins, which contribute to the colloid osmotic pressure and help substances that are poorly soluble in plasma to bind for transport. Globulins are plasma proteins that are subclassified into alpha, beta, and gamma. Alpha and beta globulins work mainly as transport proteins, while gamma globulins help in defense against infection, also known as antibodies, and fibrinogen works as a blood clotting agent. Plasma proteins are mainly synthesized by the liver, except antibodies, which are created in lymphocytes. So now let's talk about red blood cells. Erythrocytes are the most abundant cell type in the blood, with about 5 billion per milliliter of blood. So their main function is to just get oxygen throughout the blood to the tissues, and then remove the carbon dioxide back to the lungs so they can be exhaled. The way that they are structured is great because they're flat and inverted on both sides, so that allows them to have a large surface area for oxygen diffusion. They also have a flexible membrane, which allows them to squeeze through very small capillaries and deliver oxygen to areas of the body without breaking down, which is also really cool. So now let's talk about hemoglobin. So it's only found within red blood cells, and it consists of a globin protein that's made of 4 polypeptide chains and heme groups, which are 4 non-protein groups that contain iron. So each iron atom can combine with 1 oxygen molecule. So that means that each molecule of hemoglobin can carry 4 oxygen molecules. So it's very efficient. It also provides the red and blue colors associated with blood that you see on a lot of charts and diagrams. So with oxygen, it will have a reddish appearance, and without oxygen, it will have a bluish appearance. So this is why arterial blood is reddish in color and venous blood is bluish. And hemoglobin can also combine with carbon dioxide to remove it from tissues and carry it back to the lungs for expulsion, as well as carbon monoxide if that is inhaled. It can also transport hydrogen ions and a portion of ionized carbonic acid, which allows for pH buffering, as well as nitric oxide, which helps to relax and dilate the arterioles, causing vasodilation, which also just makes sure that oxygenated blood can travel freely and stabilize blood pressure so all the oxygen can get to the tissues of the body as it needs to. So now we're going to briefly cover glycolytic enzymes. They are carbonic anhydrase and a few of the non-renewable enzymes that remain within mature erythrocytes. So glycolytic enzymes generate energy to fuel an active transport mechanism that maintains proper ionic concentrations within the blood cell. And carbonic anhydrase helps with the transport of carbon dioxide through helping with the formation of bicarbonate ions. Now let's move on to leukocytes. They are highly involved in the body's defense system, immune system, and work to fight against evading infections. The immune system works in defending against microorganisms such as viruses and bacteria. They remove waste such as old or damaged red blood cells and identify and heal wounds and tissues. So there's 5 types of leukocytes. There's neutrophils, eosinophils, basophils, and monocytes and lymphocytes. So we got all 5 types, and they fall within 2 categories according to both their nuclei and if they contain granules in the cytoplasm and how many they contain as well. Neutrophils, eosinophils, and basophils fall within the polymorphonuclear granulocyte category. Their nuclei have several lobes, and their cytoplasm contains membrane-enclosed granules, and a lot of them. And then we have our monocytes and our lymphocytes are mononuclear, which means they have one nucleus and granulocytes because they do not have that many granules in their cytoplasm. So let's cover neutrophils and basophils quickly. Neutrophils are phagocytic. They engulf and digest bacteria, and they also release antimicrobial proteins. They can also do kind of a suicide bomber move where they undergo programmed cell death to kill off nearby bacteria. Neutrophils are regarded as the first line of defense against invaders in the body. So let's move on to basophils. They synthesize and store histamine and heparin, which can be released according to a triggering event. So histamine is released during allergic reactions, and heparin removes fat particles from the bloodstream. So after you eat a very fatty meal that removes those particles from the bloodstream, it also prevents clotting and helps in immune responses. So we have monocytes next. They also perform phagocytosis and settle in various tissues and grow until they're considered to be macrophages, which are much larger. Lymphocytes come in 2 types, B and T lymphocytes, and are immune defense against specific targets. B lymphocytes work to create antibodies, and T lymphocytes directly destroy specific targets through chemical release and the creation of holes in the target cell. This is a process called cell-mediated immunity. And then we have eosinophils, and they are associated with allergic reactions and internal parasite infestations. So their numbers increase when an allergic reaction occurs. And they also can get rid of a parasitic infection by attaching to the parasite and releasing toxins. So let's move on to platelets, also known as thrombocytes. Platelets are cell fragments. They're not full cells, they're just cell fragments. And they are from the outer edges of bone marrow cells called megakaryocytes. So one megakaryocyte can produce about 1,000 platelets. And even though they are only useful for about 10 days, they are very essential in the formation of blood clotting. So we have a hormone called thromboprotein, which increases the number of the platelet creating megakaryocytes so they can become more available as needed because they don't last very long. They do not contain a nucleus, but they do have some organelles and a cytosolic enzyme system, which helps them generate energy and create secretory products, which are then stored in the granules in their cytosol. They congregate at broken blood vessel sites through the exposure of collagen that attracts them, which is what is exposed when a blood vessel breaks and there is blood leakage. And collagen also helps the platelets to activate. So normally platelets are smooth and disc-shaped, and the collagen helps them to activate and change their structure into a spiky structure, which helps them stick together more and as well as stick to that collagen to stop the blood loss. And that is my presentation.